So today, this is what we're going to be looking at. It's similar to what we were doing before, but we will have a region that is bounded by two different equations, and it will not touch the axis we're rotating around, or it will not touch everywhere. So if we look at this region right here, if it is rotated around the axis here, you can see you end up with a hole in the middle of the item that you are looking at. And so if they take this little piece out, and you're looking at, rather than a disc here, you'll call these are called washer methods, because the washer, has the hole in the middle of it. So this is what we're looking at here. Here's another one. Watch this one. The image says like a So let's just start with this problem right here. So I've got sort of like a bullseye looking figure here. I'd probably do a real quick picture of it. So we used to do this. We used to do geometric probability in geometry back whenever we taught geometry. And so, like, if I wanted to know the probability that a dart thrown randomly at the dartboard would fall in that shaded region there, then I would take that area of that shaded region and put it over the entire area of the whole dartboard. So if I'm looking for that area of the shaded region, which is what I'm really concerned with, how would I find the area of that shaded region? Mm-hmm. Good. So we'll take the outside circle and subtract the inside circle. And really, this big circle on the outside is not really necessary, but I just wanted to make it look sort of like a dartboard there. This is a 2 right here, and then you have a 4 and a 4. So we'll take the area of the outside radius, which would be from that center all the way to the edge. How far is that? It is 6 inches. And then the inside radius is 2 inches, right? So we'll say pi times 6 squared minus pi times 2 squared. And so that'd be 36 pi minus 4 pi. So we'd get 32 pi overall. Okay, so the same idea is going to be true whenever we start doing this 3D. We're going to be looking at the outside radius minus the outside circle minus the inside circle for these. So here is our first example that we're going to do. And you can write down as much of that as you want, but you need those two equations and the fact that you're revolving it around the x-axis. So we have to find the volume revolving the region bounded by the graphs of square root of x and y equals x squared about the x-axis. So first we need to figure out where those two intersect so we have an idea of what this graph is going to look like. So if I set these equal to each other, I've got square root of x equals x squared. What would I do to solve that? I would probably square both sides. You could square both sides or square root. I think it's going to get us further to square both sides because this will give us x equals x to the fourth. And then I could move everything to one side, so I'll have x to the fourth minus x. And then how would I solve that? Factor. So I'll have x times x to the third minus 1. So x will equal 0, and x to the third minus 1 will equal 0. So that'll be x to the third equals 1. So x will equal 1 whenever we take the cube root of both sides. So from 0 to 1 is where we're looking at. If we think about graphing this, because we're going to need to have a picture of this, I think this is a little bit difficult to do. We know that both are going to go through 0, 0, and both of these go through 0, 1. So the square root of x, you got to kind of know what the picture of that looks like. It's going to curve like this. It's concave down. And then y equals x squared, that is concave up. And it's important that you know that because you need to know which one is going to be the top function and which one's going to be the bottom function, or which one's going to be the outside radius and which one's going to be the inside radius. So what we'll be doing here is we're taking a slice like this and we're rotating that slice around the x-axis. So, you know, if you kind of think of what that's going to look like, you can sort of get that picture of that washer you're going to have there. And so we need to be thinking about an outside radius and an inside radius here. So if we're looking at that washer, which function is on the outside? Which one gives you the outside, forms the outside of that washer? The square root of x, that red line, right? So I'm going to use a capital R for my outside. So that's the square root of x. And then I'm going to use a lowercase r for my inside radius. Which one's the inside radius? X squared. Now, you have to do these separately. They cannot be put together. Like, we're not going to do square root of x minus x squared and then square it. We're going to do them separately. Because here, we did not do 6 minus 2 and then do, that would be 4, and do pi 4 squared, right? That we did not do that. That'd give us 16 pi. It'd be wrong on this one. So you have to square them separately. You do not subtract them, then square them. And that's the biggest mistake I usually see students make on this. So what you're doing is you're taking the integral from 0 to 1 of the square root of x squared, and you need a pi out here, minus pi times the integral from 0 to 1 of x squared, and I really should put a dx with both of these. Now, I could combine some of this, but only if I'm squaring my functions separately. So, like, I could, if I want, these both have pi's, and they're both integrated from 0 to 1. So if I want, I can write it this way, pi from 0 to 1 of, and then square root of x squared is going to be just x, and then x squared is x to the fourth, and put the x here. But they must be squared separately. Plus, it's easier to do if you square them separately because the square and the square root cancel out nicely there. So, so for this, we're just going to integrate. So the pi will stay out here. We will have 1/2 x squared minus 1/5 x to the 5th. And what value evaluate that from 0 to 1. So this isn't too bad. We'll have 1/2 times 1 squared minus 1/5 times 1 to the 5th. And then we'll subtract. We'll plug in 0. We'll just get 0 there. So 1/2 minus 1/5, that's going to be 5 over 10 minus 2 over 10. So we will get 3 pi over 10 for our volume here. So it's very similar to what we've been doing, but sort of like whenever we do our area, we got to think outside radius and inside radius, right, Joe? So here's our next one. So we've got the square root of x plus 1. The plus 1's not underneath the square root there. And then we've got x squared plus 1. And here we're going to look at rotating around the x-axis and around the y-axis. Correct? Okay, so for this one, if we think about the graph of this, this is almost the exact same problem we had before. It's just the square root of x has been moved up 1 and the x squared has been moved up 1. So if we think of the graph here, the square root of x plus 1 will look like this, and x squared plus 1 will look like this. That area that we're rotating around the x-axis, that shape is really just the same as what we had before, right? Is the volume going to be the same? It is not, because what's going to look a lot different about this figure when we rotate it than the one that we just did? It's got a lot bigger hole in the inside of it, right? The other one didn't even really have a hole down here at this end. It sort of made like a weird sort of bowl shape with curved sides. This one is going to have a hole all the way through. So whenever we do this problem, we're still thinking about this here, and we're thinking outside radius minus that inside radius. So in this case, Joe, which one is my outside radius? Square root of x plus 1. So I will have the square root of x plus 1 squared. And then I have to subtract my inside radius squared. So for this one, it's going to be x squared plus 1 squared. And then we'll have a dx. Here, for this one, I went ahead and put them all in the same integral, but notice I am squaring these separately, right? Because we're doing power squared here and power squared here. And so this one is a lot more difficult to solve by hand because we have to multiply both of these out. So we're going to have, here we've got to square, double square, so the square root of x squared is x. Then we'll have the square root of x plus square root of x, so that'll give us 2 square root of x plus 1. And then here we'll have x to the 4th plus 2x squared plus 1. And so the plus 1 and the minus 1 are going to cancel out because we'll be subtracting all of these. So we will end up with, if we put them in order, we've got x to the 4th minus 2x squared plus x plus 2 square root of x. I'll post these on Canvas, and your homework will be from the book tonight. Okay. Questions so far? Okay. So we're going to integrate. So we'll have pi. Oh, wait, do not need the integral symbol once we have integrated 1/5 x to the 5th minus 2/3 x to the 3rd plus 1/2 x squared. And then let's see, this is x to the 1/2, so this will be x to the 3/2, and then we've got to do 2 divided by 3/2. Dividing fractions is easy as pie. Flip the second and multiply, so we'll get 4/3 there from 0 to 1. And for the sake of time, let's just cheat on this and use our calculator. So we'll have 1/5 minus 2/3 plus 1/2 plus 4/3. And so that's going to give us 41 over 30, so we'll have 41 pi over 30. I think it's cool. All right, we're going to do this, we're going to do the same problem. We're going to revolve it around the y-axis. Yes. So I'm going to copy down those equations here so I can see them. We had y equals the square root of x plus 1, and we had y equals x squared plus 1. And this time, if we think about that region, I'm just going to graph it real quick. We have the square root of x plus 1, and we have this. So we're taking this region, and hey Gabby, thank you. If I've ever had the number of kids in the class fluctuate so much in a day, ever. Everybody's been called out or left or doing something. Alright, so whenever we think about rotating around the y-axis, we're taking like a horizontal strip right here, and we're rotating that around that y-axis like so. So the outside radius and the inside radius here are going to be different than when we rotate around the x-axis. Also, if we're rotating around the y-axis, everything has to be in terms of y instead of x. So what we're going to need to do here is we've got to solve both of these equations for x. So we would subtract 1 from both sides here. We'll get y minus 1 equals the square root of x. And then we would square both sides. So we would get, I'm just going to leave it y minus 1 squared for right now. So that is the blue line right here. This is x equals y minus 1 squared. And then y equals x squared plus 1, I would have, that'd be y minus 1 equals x squared. I would square root both sides. So x would equal, you'd use plus or minus the square root of y minus 1, but because this is just the part on the right-hand side, we're going to use the plus, so we'll have the square root of y minus 1. So x is the square root of y minus 1 here. Okay, so whenever we look at that section that we're rotating around, which one is the outside radius, the red line or the blue line? The red would be on the outside, right? So we would have pi, we would integrate, we would have the outside radius, which is the red, so that's square root of y minus 1 squared. And then we'll have the inside radius, which is the blue here, so that'll be y minus 1 squared squared. And we'll put a dy out here. What should my limits of integration be here? They are 1 to 2, because we're pulling that, since this is in terms of y, we're pulling those from the y-axis here. So from 1 to 2. And so this one is not, this one's worse to solve than the last one, because we're going to have pi, integral from 1 to 2. This part's not bad, we just have y minus 1. But over here, we're going to have y minus 1 to the 4th power. If you find yourself having to do this by hand, if you'll recall, it's been a long time since we did it, but you can use Pascal's triangle to do this. You guys remember doing this long ago? 4, 6, 4. So, like, the outside is always 1. To get each number in the next line, it's just the numbers, the two numbers above it, like that. So since we're raising it to the 4th power, we would need this is 0, 1, 2, 3, 4th line is what we need. So this will save us some time if we have to do this by hand. Hopefully we won't have to, but just in case we do, we would have y to the 4th. Here, the signs are going to alternate between positive and negative because we have this negative 1 here. So we'll have minus 4y to the 3rd plus 6y squared minus 4y plus 1. Or you can write it 4 times and multiply it out. And so we got to distribute that negative. So y minus 1 minus y to the 4th plus 4y to the 3rd minus 6y squared plus 4y minus 1 dy. And so we'll have negative y to the 4th plus 4y to the 3rd minus 6y squared. We're going to get plus 5y minus 2. And I'm going to assume we know how to integrate this by hand. And since we do know how to integrate this by hand, let's use the calculator to integrate this, because otherwise, just even typing all the 1s and 2s in is going to be long. So let's just, it's still kind of long to type in this way. So we'll have the integral of negative x to the 4th plus 4x to the 3rd minus 6x to the 2nd plus 5x minus 2, comma x, comma 1, comma 2, So we get 3 over 10. And I did not put the pi in whenever I typed that in, so it's going to be 3 pi over 10. On your homework, when you get one like this, I'm very concerned that you know how to set it up correctly. But if you want to use your calculator, one that's going to be like super long like this after that, that's okay. Notice what we've got here. This is the same as we had on our first example, 3 pi over 10. Because if you think about what these would look like, whether you, since that's symmetric right there, whether you rotate it around the x or around the y, it's going to look pretty much the same. So we get the same answer there. It's just this was a lot harder to do than the other. All right, let's do this one here. So this time we've got y equals x squared minus 4x and y equals x minus 4, and we're going to rotate around the x-axis. Okay, so for this one, I kind of know what those graphs look like, but not. I know this is a line. That one's not too bad to graph. This one, I can find the x-intercepts pretty easily. But what I would probably do here is find your intersection points. So you have x squared minus 4x, and we want to know where that equals x minus 4. And so to solve that, we will move everything to one side. So we'll subtract our x. We will add our 4. So x squared minus 5x plus 4 will equal 0. And so if we factor that, we'll have x minus 4 and x minus 1. So we get x equals 4 and x equals 1, our intersection points. So just to get like a rough graph of what that looks like, I'm going to have a, this, if I factor it, is x times x minus 4. So that's going to have x-intercepts at 0, 0, and 4. So I'm going to have something that looks like this. And then, I guess I should move this down a little bit. And then I've got a y-intercept here at 4. And so that line will look, let's see, at 1, we'll have an intersection here, 4. So we've got this point to this point, so we're looking at this area right here. So this one's a little bit different because it's below the x-axis instead of above. So be careful when you do this because everything so far it's kind of been top minus bottom, but you're thinking inside radius and outside radius. So we're thinking of taking a little section right here, and we're going to rotate that around the x-axis. So this one will do like that, and this one here. So the outside radius, which equation is the outside radius? The quadratic or the line? The quadratic, good. So the quadratic is our outside, the line is our inside here. So when we set this up, we're going to have the integral, so pi, the integral. What are our limits on our integral? Not 0 to 4, 1 to 4. And then we'll have the x squared minus 4x squared minus x minus 4 squared. And so we're going to have, I do want you guys on the homework to be multiplying this out because I'm afraid you're going to get some of these that are going to be calculator inactive. And this, although it's something that we do a lot earlier, it's something kids mess up a lot of times. So if we square this, we're square, double square. So we'll have x to the fourth minus 8x to the third plus 16x squared. And then we'll have minus x squared minus 8x plus 16. And then we'll distribute that negative, so this will make this a minus, this will be a plus, this will be a minus. So we'll have pi, the interval from 1 to 4, x to the fourth minus 8x to the third, and we'll have plus 15x squared plus 8x minus 16. And then because this is going to be so long, if you have to write it out, because you're getting fractions, you're getting all kinds of stuff you got to deal with there. Actually, you might not get too many fractions on that one. Fractions won't be so bad, but still, you got a 1/5 here. I'm going to let you guys use your calculator for this, just so that homework doesn't take days to do. So we'll have x to the fourth minus 8x to the third plus 16x squared plus 8x minus 16, comma x, comma 1, comma 4. And so we get 1/8 over 5, and we'll have the pi. There we go. So 1/8 pi over 5. Okay. Questions? Alright, so this is not right. This is from the old book. Your assignments is going to be page 425, and you're going to do 5 and 6. They have the graph for you, so that's helpful. And then 13 through 16, but I only want you to do any of them that say for the x or the y axis only, because there's a few there, like it's got a part A, B, C, D, and they'll ask you to rotate around like the line x equals 1 or y equals 2, so you can skip those parts to ask for those. And then I want you to do 43 through 49 odd. And that also already